So what are the two methods we've talked about solving systems of equations so far? What two methods have we used to solve systems of equations? Substitution. What else do we use? Graphing. Good job, everyone.
Thank you.
Good job. So we used graphing and substitution, correct?
Yeah.
We're going to use the third and final method today. It's called elimination. Hopefully you kind of remember this from Algebra 1. Once again, this is all review from Algebra 1 so far. So here's the steps we use to solve by elimination. We first want to line up the equations. What I mean by that, we want to line up all of our x values. We want to line up all of our y values. We want to line up our constants. We want them all to be in the same column. Step 2. We want to multiply one or both equations by a number to result in a variable with the same coefficient. Everyone knows what a coefficient is?
Yes.
What is it?
That's not the y, but it's the number right next to the y, right?
Number in front of a variable is a coefficient. So in one of my columns, either the x column or the y column, I want to have the same exact coefficient. So if the x is a 3, I want to get it to a 3. Or if I'm dealing with the y's and I have a coefficient of 5 in front of a y, I want to get the other one to have a 5 in front of it. I want them to have the same coefficient in front of them. Step 3. Add or subtract the equations to eliminate this variable. So if they already have opposite signs, I can just add them and they'll cancel out. If they have the same sign, I'm going to have to subtract them. That way they cancel out. Because this process is called what?
Elimination.
Elimination. So my goal is to eliminate one variable right off the bat. Does that make sense? Step 4, solve for the remaining variable. And step 5, once again, our answer is what? And starts with an O and it's two words.
Oval.
First word starts with an O.
Operation.
Second word starts with a P.
Ordered pair.
Ordered pair. My answer is an ordered pair. So for my last step, I once again need to substitute my answer from step 4 into either original equation to find the other variable. Are there any questions about any of the steps we're going to follow? Okay, let's look at the first one. We have x plus 7y equals 17. X minus y equals negative 7. Step 1. What's my first step?
Solve it.
Line up my equations. Are my equations lined up where they need to be?
Yes.
Yep, I got my x's in the same column. Got my y's in the same column and my constants in the same column. And we're good with that first step. What's my second step?
Multiply.
Multiply one or both equations to get the same coefficient in front of one of the variables. Well, let's look at our variables real quick. Do either of my set of variables have the same coefficient?
One set does.
No. Wait.
What?
Yes.
Do either of my variables have the same coefficient? Do my x's have the same or do my y's have the same? X's. What are the coefficients in front of x?
1.
1. Does everyone agree that they have the same coefficient?
Yes.
Heads up, please. Thank you. So do I even need to do step 2? Do I need to multiply by anything?
No.
No, I don't. Step 2 is already done for me. Step 3. What is step 3?
Add or subtract the equations.
Add or subtract the equations to eliminate a variable. In front of the x's, do they have the same or opposite signs?
Same.
Same. They're both positive. So do you think I'm going to add here or subtract to eliminate x?
Subtract.
Subtract. So I'm subtracting my bottom equation from my top equation. X minus x would give me 0. It gets eliminated. It's a process of elimination. Okay, we got to be careful with our signs here. I have 7y minus negative y.
So you would add one.
So I would add them, right? Because two negatives right next to each other makes a
Positive.
positive. So what's 7y plus y? 8y. Once again, be careful with your signs here. 17 minus negative 7. What would that give me?
24.
Positive 24. Are there any questions with any of the steps I've done so far?
So, okay, so how are we gonna have to do?
Not yet. We still got to get y, and then we got to get our other variable also.
Wait, so you can just like change if it's negative or positive? Like you just make whatever you want? Because like it's
No.
negative y. So they subtract it.
We're subtracting, remember? We're doing the top equation minus the bottom equation. So it's
Okay.
7y minus
Okay.
negative y, right?
So state change.
State change change. So it becomes 7y plus y. Same thing with the 17 minus negative 7. You got to be careful with the signs here. Everyone good with that? Okay, so now I'm just solving for y. That's my next step, right? Solve for the resulting variable. How do I solve for y here? Divide by
8.
8 on both sides.
So y equals 3.
Y equals 3. There's my y value. Am I finished? No. I need it as an ordered pair, so I need my x variable also. So what am I doing to get my x?
You don't
Plug in
replace
y.
Plug in. Does it matter which equation I use?
No,
No. Which one do y'all want to use?
bottom.
Bottom. I heard bottom first. We have x minus, what's my y value? 3 equals negative 7.
So wait, so I did it the other way. It's the same answer.
You plugged it into the other
The
equation?
way we just learned. I just did that and got the same answer.
You use substitution?
Yeah.
Well, it's
What's x equal?
what do the directions say at the top of the paper?
Yeah, do that.
Use elimination, right?
Yeah.
I want you to use elimination for today, and then once you get these in the future, and it says use any method, you can use whatever method you want. Okay.
So we can do what we did yesterday.
You can do, listen, there's too much talking. That's a great question. She asked, can I not use the top one because I use that one? Yeah, you can use the top one. You can use either one you want. Okay? You should get the same answer. How do I get x by itself here?
Add 3.
Add 3. What does x equal?
Negative 4.
Negative 4. Is this how I want your answers?
Nope.
How do I want my answer?
In the ordered pair.
Negative 4,
Remember.
3.
Negative 4, comma 3. That is my answer.
So you think this?
Are there any questions on number 1?
I didn't get that.
What'd you get?
I don't even know. But it's not that.
Here, let's plug in.
You get the decimal.
X plus 7 times 3 equals 17. 7 times 3, 21.
Oh, wait, never mind. I know right next door.
Subtract 21. X equals negative 4. Same answer.
I did it wrong.
Questions on number 1?
No,
We all right with number 1? Okay, number 2. 3x plus 2y equals 22. 5x minus 2y equals 42. Step 1. What's step 1? Line them up. Are they already lined up?
Yes.
Perfect. I don't have to do step 1. Step 2.
No.
Multiply one or both equations to get the same number in front of one of your variables. Let's check our variables. Does x have the same number in front of them?
No.
No. Do the y's?
Yes.
Yes.
Yes. If we're not looking at the signs, they do have the same number, right?
Yeah.
Yeah.
So now I just have to figure out if I need to add or subtract to eliminate it. Do I add the two equations or subtract them?
Add.
Add them. Here, let's look at it real
How do you
quick.
even know?
So I'm looking at the signs. Previous slide, listen,
That's number 1.
listen. Quit talking. Previous slide. We had the same number in front of x. They had the same sign, right? If I added them, I would have gotten 2x. I have to subtract them to eliminate it. Here, they have opposite signs. If I subtract them, I'm going to get 2 minus negative 2, which is 2 plus 2. So I have to add them, so that way they get canceled out. So I'm just essentially looking at the signs that are in front of them. If they have the same sign, I'm subtracting. Opposite signs, I'm adding. Okay? You may want to write that little note on your paper. Same signs you're subtracting, opposite signs you're adding. Okay? Does everyone see why that is the case? Okay, so we're just adding down our columns. What's 3x plus 5x? 8x. 22 plus 42. 64. Is everyone with me so far? I'm moving too fast. I can slow down if I need to. How would I get x by itself now? Divide by 8 on both sides. So what does x equal? 8. There's my x value. Raise your hand if you want to tell me which equation you want to use to plug into. Nathan. Top one. 3 times 8 plus 2 times y equals 22. I probably would have picked that one as well because we're dealing with smaller numbers. Once again, you can use either equation though. Either one will give you the same answer. 3 times 8? 24. Plus 2y equals 22. Raise your hand if you can give me my next step. Subtract 24 from both sides. Do I want to see all your work? Yeah. Always. I always want to see all your work. Make sure you're showing your work when you're solving for these variables. 22 minus 24. Negative 2. Raise your hand if you can give me my last step. Preferably someone who hasn't answered yet. Yes? Divide by 2 on both sides. What do we get for y? Negative 1. So what's my answer? 8 comma negative 1. If you put negative 1 comma 8, you're wrong. Make sure you get the ordered pair in the correct order. X always comes first, y always comes second. Are there questions on number 2? We all right so far? 3. 4x minus 9y equals negative 42. X plus 5y equals 4. Are my columns already lined up? Yep, I got x's above x's, y's above y's, constants above constants. Do I have the same number in front of either variable? No, I got 4 and 1 in front of x and negative 9 and 5 in front of y. So raise your hand if you have any ideas which equation or both equations I might need to multiply by what number. Nathan. Very good. That's going to be the easiest way to do it because I'm only going to have to multiply the bottom equation. If I was trying to eliminate my y's, I'd have to multiply both equations by something. Everyone see that? No. What's your question? We're multiplying the bottom equation by 4. We want to eliminate a variable. So we can do either x or y. But if I wanted to eliminate y first, I'd have to multiply both equations by something. Right? If I want to eliminate x, I only have to multiply the bottom by 4 because that one's already a 4 and I can get this one to 4. If I wanted to get the y's to something, it'd have to be something like 45. Have to multiply the bottom by 9 or the top by 5. Does everyone see that? Like to do as little work as possible. We still got to show our work. So we're multiplying the bottom equation by 4. So I'm multiplying every single thing in that equation by 4. What's 4 times x? 4x. 4 times 5y? 20y. 4 times 4? 16. Any questions how I got that? Now, do I have the same number in front of one of my variables? I've got a 4 in front of both of my x's, right? So I'm no longer looking at this middle equation. I'm looking at the top and my new equation. Do they have same or opposite signs? The x's. Same sign. They're both positive, right? So am I adding my two equations or subtracting? Subtracting. Because 4x minus 4x gives me not x. They just cancel each other out, right? Negative 9y minus 20y. Negative 29y. Negative 42 minus 16. Negative 58. Everyone good with what I've done so far? Any confusion there that I need to clear up? How do I get y by itself? Divide by negative 29 on both sides. What do I get for y? 2. Positive 2. Everyone okay with how I got y equals 2? Okay. Now I'm plugging in to get my x variable. I now have 3 equations, right? I can pick any of those 3 original. I can pick this top one, this middle one, or the new one I came up with. What do you think you want to use to plug in? Middle. X plus 5y equals 4. So we get x plus 5 times 2 equals 4. 5 times 2? 10. How do I get x by itself? Subtract 10. X equals negative 6. So what's my answer? Negative 6, comma 2. Any questions how I got to that conclusion? Any confusion at all? We all right? Can I move on to 4? Isn't this the most fun stuff you've ever done in your life?
Wait, go back.
Freshman year?
What?
Oh, it's better than what we did in freshman year.
Yep.
Okay.
Okay. Number 4, 7x minus 6y equals negative 53. 2x minus 3y equals negative 13. Are my equations lined up? Yeah, they are. X is in the same column, y is in the same column, constants in the same column. Do I have the same number in front of either of my variables? No. Is one going to be easier to eliminate than the other? Which one's going to be easiest to eliminate?
Why?
Why you say that, Trey?
Because.
Because
Because you got times 2.
I got to multiply the bottom by 2, right? Do I have to multiply the top by anything? No, I do not. I've only got to multiply one equation by something. So multiply the bottom by 2. 2 times 2x. 4x. 2 times negative 3y. Negative 6y. 2 times negative 13. Negative 26. Now do I have same number in front of my variables? Yes. Are they same or opposite signs? Same. They're both negative, right? So am I adding or subtracting? Subtracting. If they're the same signs, you subtract. So once again, not looking at this middle one for now. I'm just looking at that top equation and that new equation I got. 7x minus 4x. 3x. Negative 6y minus negative 6y. They cancel each other out. Negative 53 minus 26. Actually, negative 53. Here we go. We got to pay attention to our signs.
I'm confused.
What's up?
Shouldn't that be 11x?
It's 7x minus 4x.
Oh.
We're subtracting the two equations.
I thought it was negative, sorry.
Nope, you're good. So we have negative 53 minus negative 26.
Negative 30? No. Minus 26. Wait.
30.
Station. Wait.
So I have negative 53 minus negative 26.
Negative 79.
So negative 53 plus 26. You guys have calculators, right?
27.
Nobody should have.
Yeah, negative
30, 70,
What?
12.
Negative 27, right?
Yeah.
Any confusion there?
Oh, I put 56.
Confusion? Question? Because remember, listen, quiet. We got to pay attention to our signs. We've got negative 53 minus negative 26. So if I have two negatives next to each other like that, they become positive. Stay, change, change. How do I get x by itself now? What? Divide by 3. X equals negative 9. Okay, plugging x in to one of my originals. Do I want to use my first, second, or third equation? Second. I agree, it's got smaller numbers. So 2 times negative 9 minus 3y equals negative 13. 2 times negative 9. Negative 18. What's my first step to get y by itself? Add 18 to both sides. Negative 13 plus 18? 5. How do I get y by itself? Divide by negative 3. Y equals negative 5/3. So what's my answer?
9.
There's my answer. What can you always do if you're ever unsure about your answer?
Double check.
Check your solution. Plug it into both your original equations. See what you get out of the deal. Any questions about number 4? We might have some time to knock some of the assignment out today. Can I move on to number 5?
Wait, hold on.
Can you
Okay,
multiply
Gosh.
each equation by different number?
Mm-hmm.
I'm good. You're good.
Moving on. Number 5. 5x plus 3y equals negative 7. 2x plus 7y equals 3. Step 1, are my equations lined up? Yes, they are. Step 2, do I have the same number in front of either of my variables? No. Am I only going to be able to multiply one equation, or am I going to have to multiply both equations by something? Both. So what do we think is going to be the easiest to eliminate, x or y?
Y.
X.
Well, you can do either.
Yeah.
I think x would be easier, because what can I multiply top and bottom by?
2 and 5.
2 and 5, right? What would I have to multiply top and bottom by if I wanted to eliminate y?
7 and 3.
3 and 7. Those are bigger numbers, right? I like to deal with the smallest numbers as possible. Does everyone see how we're getting why we're multiplying by 2 and 5, or why we're multiplying by 3 and 7? Because I'm looking at the numbers in front of x. What's the least common multiple of 2 and 5? 10. So I'm trying to get them both to 10. If I wanted to eliminate my y's, what's the least common multiple of 7 and 3? 21. So I'd want to multiply by 7 and 3. Okay? So let's multiply the top by what? 2. And the bottom by 5. Okay, 2 times 5x. What? 10x. 2 times 3y. 6y. 2 times negative 7. Negative 14. 5 times 2x. 10x. 5 times 7y. 35y. 5 times 3. 15. Questions on what we've done so far? Okay. I have the same number in front of x, correct? Do they have same or opposite signs? Same. So am I adding or subtracting my two equations? Subtracting. So we got to pay attention to signs here. What happens to my x's? Cancel out. Am I moving too fast? Okay. 6y minus 35y. Negative 29y. Everyone okay with that?
Yeah.
Negative 14 minus 15.
29. Oh,
Negative 29. And now how do I get y by itself? Divide by negative 29. So y equals
1.
1. Perfect. Questions how I got y equals 1? Okay, I've got 4 equations now that I can choose from. Do I want to use first, second, third, or fourth to plug my 1 into? Second. We've got 2x plus 7 times 1 equals 3. 7 times 1. What's my first step to get x by itself? Subtract 7 from both sides. 2x equals negative 4. How do I get x by itself? Divide by 2 on both sides, so x equals negative 2. What is my answer? Negative 2, comma 1. There's my answer. Questions on number 5? It's good stuff, huh?
Yeah.
Just wait till we solve systems of equations in 3 variables. That's good stuff right there. That is great stuff. Guess what we're doing after solving systems in 2 variables? Solving in 3 variables. We get to do that after this.
You know what? I'm so proud I have you as my teacher. And I can just walk there and ask for help.
Do what?
What?
You should cheat. What is it?
What
No
did you say?
disrespect to you.
Questions on number 5? Can I go to my last example?
Yes, you can. Is it nice?
Okay. 3x minus 9y equals 9. 4x minus 12y equals 36. Are my columns lined up? Yep, they are. Do I have the same number in front of one of my variables? No, I don't. What's going to be easiest to eliminate, x or y? Both?
Yeah.
I think why?
4, 3.
So which variable are we eliminating?
Both teams.
Both of them?
No.
Well, let's try to eliminate x first, okay? Let's try to eliminate it. What would I have to multiply top and bottom by to get my x's to have the same number?
The top 4, the bottom 3.
Multiply the top by 4, bottom by 3. 4 times 3x,
12x.
12x. 4 times negative 9y,
Negative 36.
negative 36y. 4 times 9,
36.
36. 3 times 4x,
12x.
12x. 3 times negative 12y.
Negative 36.
Negative 36y. 36 times 3.
108.
108. Okay, do my x's have the same number in front of them now?
Yeah.
Or do they have same sign or opposite sign?
Same sign.
Same, so am I adding or subtracting my equations?
Subtracting.
Subtracting. What happens to my x's?
Cancel out.
Cancel out. What happens to my y's?
Cancel out.
They cancel out.
Cancel out. What's 36 minus 108?
Negative 72.
Negative 72.
Negative 72.
I was trying.
If everything cancels out on my left-hand side, what number would I be left with?
0.
0.
So it's
Does 0 equal negative 72? No, it does not. Does it? So is that true or false statement? False. It does not equal negative 72. So what's my answer here?
No solution.
No solution. You can either write it out,
Yes.
or you can use the circle with the slash through it. Okay? Does everyone see that?
Yep.
We're good with that? Questions there? Let's say that instead of that being a 36, it was a 108.
0.
What's 108 minus 108?
0.
0. Is that a true or false statement?
True.
True. So what would my answer be?
Infinite solution. I said first.
Stop saying my word. Infinite solution.
Whoa, 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 whoa.
He was trying to say infinite.
Infinitely
Infinitely.
many solutions.
I'm done with this.
Does everyone see that? So once again, if your variables cancel each other completely out, you're left with a false statement, you get no solution. If they cancel each other completely out, you're left with a true statement, you get infinitely many solutions. If they don't cancel each other completely out, you just get one solution, which is a one-order pair. Okay? Any questions about solving systems of equations by elimination? Are there any questions about any of the examples
No.
we have gone over?
No.
Not too bad. Which method do you like the best? Graphing, substitution, or elimination?
Either one.
What?
One.
Elimination.
Elimination.
I don't like graphics.
Anyone like graphing best?
I like it. It's
Depends
easy.
on it.
It's easy.
It's easy. So
Anyone like substitution best?
Yeah, I like it. It's easy.
No, it's okay. I like this one.
How many of you are indifferent? You like? It doesn't matter which one you're using. Honestly, it just depends on what you're given. Some equations are easiest to solve when graphing. Some are easier to solve when using substitution. Others are easier to solve using elimination. It just depends on what form of the equations you're given. Okay? So, tomorrow, we're going to get an assignment over this. We'll have our shortened schedule due to Titan time. You'll get an assignment over this tomorrow, though. So, nothing tonight. You're welcome.
Cool beans.
And then, listen, don't go have a seat. Go have a seat. I'm still talking. So tomorrow we'll solve using elimination still. And then Thursday we'll probably get into some word problems, solving systems of equations using word problems. Okay? So they'll be good application problems for us. And then sometime next week we will start solving systems. Sit down. Sit down. I'm still talking. Sometime next week we will be solving systems of equations that involve 3 variables. So how many equations will we have total? 3. So our equations could look something like this.
Guess what?
That's what our systems are going to look like when we have 3 variables. Guess how many variables we're going to have to solve for? All 3. We're going to have to find x, we're going to have to find y, and we're going to have to find z.
What is Z?
It's called an ordered triple instead of an ordered pair.
What would Z
Okay.
be graphed as?
We won't graph it.
But like,
That's
oh.
it's a third axis, essentially. So, just a heads up, sometime next week, this is what we're going to be getting into, is solving systems of equations in 3 variables. It's kind of a long, tedious process, but it does involve some of the process we use to solve systems in 2 variables. So that's why I wanted to review the 2 variables first. That way when we get to 3 variables, we're not confused as crap. Okay? Are there any questions before I end my recording?